the fire drill kind of got me off track this morning. But first thing, before we go through the bell work, I will take a look at your homework. So we're going to go look at your homework, and we're looking at 3 and 4 on your homework. So I'm going to write here real quick. So number 3 on our homework. It says that acids are defined as substances that dissociate in water to produce blank ions. What do they produce? Hydrogen ions. And that formula for hydrogen ions is what? H plus. That's Arena's definition. Now, the Bronsted-Lowry definition says that acids are substances that blank ions. So, according to the Bronsted-Lowry, acids are ones that donate hydrogen ions. And if at number 4, instead of hydrogen ions for bases, what do we have? Hydroxide. And those are OH minus. And instead of donating protons, they accept the hydrogen ion. Now 9 and 10, it's going to be, if I don't go over 9 and 10 real quick and give you guys the answers, and I'll just forget about it, because it'll probably be later this week before I lecture over it. So number 9 says that acids and bases react to form blank and a blank. So if I have an acid, and these are really not Bronsted-Lowry, these are really talking about Arenas, and they have a reaction. This is a double replacement. So what's going to happen? H hooks up with OH. And we get that. And what is that called? H2O, water. So that's one thing we get in a reaction. What's the other thing we got? NaCl. And anything that is composed of a positive and a negative ionic bond is called generically a salt. Okay? So acids, bases, they come together, they make water and a salt. And what happens is acid comes in with a pH of, say, 3. Base may come in with a pH of 10. When they come together, they neutralize. What's a neutral solution? 7. So we get a pH of 7 when they come together, and that is neutral. So we call this a neutralization reaction. And then an indicator, all these are substances that change color when it comes in contact with the acid or a base. Okay. So I'm going to clear my screen, and we're going to go over the bell work. And I meant to change. Where are you at? All right, so I want to do identify acid, base, conjugate acid, and conjugate base. So HClO4, what is that? Acid. H2O is? H3O plus is conjugate acid, while ClO4 is conjugate base. Base goes with conjugate acid. Acid goes with conjugate base. H2SO3. H2O. H3O plus. Conjugate acid. So HSO3 is conjugate base. I'm going to change this up. Let me change this to so C2H3O2 minus is our water is acting as our OH minus is our, so HC2H3O2 is our conjugate acid. Okay, I'm not going to go through any more of those. Everybody good with that? Okay. So some indicators. What we're going to talk about are indicators. These are just dyes that are going to change color when they're in a pH, when they change pH. So what happens is there's all different types of indicators. One common one that we use is called phenolphthalein. And phenolphthalein is clear or colorless when it's in an acid situation. And then when it is in a basic situation, it changes pink. Okay? So what happens is I can give you a base, and I can tell you, or I can give you a base, and I can tell you that your base has a concentration of 2.5. And then I can give you an acid, and I can ask you to find its concentration. So what we do is we do this experiment that's called a titration. So what happens is in my little beaker, I have my known amount of acid, and I'm going to put my acid in there. And while I have my acid, I also have an indicator in there. And it's going to be clear because phenolphthalein is clear when it's in acidic solution. And I'm going to start dropping some base in there. All right? So we drop the base. So we sit there and we drop the base. And as we drop in the base in there, what happens is we get this pink color. And then it goes away. And then we drop some more base in there. And we get some pink color. And it goes away. And we keep doing that over and over until finally, at some point, it's going to stay pink.
Are we ever going to do a lab?
And that's called our endpoint. I hope so. That's when that would be our endpoint, when our color goes from one to the other. Okay? I usually try to do one where we will figure out what the concentration of acid is in aspirin. And we do two different types of aspirin. We do baby aspirin and we do regular dose aspirin. So titration, we're really going to talk about that later on. Litmus paper, we talked about that. Litmus paper changes color. There's red, blue. If it's red and we put something on it and it stays red, what type of solution is it? Acid. If it turns blue, it's a base. If we have blue litmus paper and it stays blue, it's a base. If it turns red, it's an acid. Okay. So this is something, self-ionization of water, or you may see it called auto-ionization of water. Water, the ones in the tap, the ones in the drinking bottle, wherever it is continuously ripping itself apart. So what happens is we have these two water molecules. They come in contact, and one water molecule will end up ripping a hydrogen from another water molecule. And when it does that, we end up with an H3O plus, which is acidic, and we end up with an OH minus, which is basic. This is continuously happening. And that's why we say that water is an acid and a base, because it's continuously doing that in that situation. Okay? It's all the time doing it, ripping itself apart. So, if we have equal molarity, if we have the same concentration of H ions and OH ions, then we are neutral. So, on your notes, if H plus or H3O plus, those are the same thing, okay? H3O plus we will also call as hydronium. if that concentration equals the concentration of my hydroxide ion, then it is a neutral solution. If we have a situation where we have more hydrogen ions than we do than our hydroxide ions, then it is what type of solution? Not neutral. Is it acidic or basic? If we have more H pluses, then it has to be acidic. If we have a solution where now we have more hydroxide than H plus, then it is a basic solution. So you'll need to look at your molarities, the concentration of these things, to determine is it an acid or is it a base. Okay? Everybody good with that? This slide? All right, next. So what happens is water, because it's consistently ripping itself apart, it has this constant. And that constant we call as Kw. So Kw is a constant. Kw is equal to the concentration of my hydrogen ions times the concentration of my hydroxide ions. Since Kw is constant, it will never, at 25 degrees Celsius, it will never change. So the value of Kw is always 1 times 10 to the negative 14. 1 times 10 to the negative 14. So, if H positive equals OH negative, that means if I take the square root of Kw, that will get me the concentration of H plus and OH minus. So square root of that would be 1 times 10 to the negative 7. Okay? So I can ask you, hey, here's the solution. It has a hydrogen concentration of 4.2 times 10 to the minus 8. What's the hydroxide concentration? Knowing that they always has to equal 1 times 10 to the negative 14, then you can tell me what the unknown is. Okay? We're going to go through this. This is telling you, again, basically the same thing that I just went in. If you need a visual need to read it, then go back and read that. But we're just going to go solve this problem. Hydrogen ion concentration. So that means my H plus is equal to 4.3 times 10 to the minus 6. What is the hydroxide ion concentration? So my OH minus is my X. And then is it acid or base? So you're going to get this problem on a test or a quiz, and you're going to go, you did not give me enough information. I don't know what to do. But we know that H plus times OH minus has to always equal 1 times 10 to the negative 14. If H plus is 4.3 times 10 to the negative 6, then we can solve for OH minus. So put that in the calculator and solve for OH minus. So OH minus is going to be 1 times 10 to the negative 14 over 4.3 times 10 to the minus 6. You need to be punching these numbers in, especially these little exponents if you are having trouble. So in your calculator, it needs to say 1. And you need to hit second E, which is above the number 7. And then you're going to put negative, not minus. You're going to do negative 14, no carets or anything else, just negative 14, divided by 4.3, second E, negative 6. And what do we get? We should get something that's 10 to the negative 9. What did y'all get? 2.32 times 10 to the negative 9 big M, or moles per liter. I will give you. I'll give you the equation. I'll say that KW equals 1 times 10 to the negative 14. You just have to know that you got to relate those two things and put it together. Anybody not get that? No?
I think it's in the wrong mode. But
Okay.
So write 1 times 10 to the negative 14 instead of doing like the second. What did you say?
The second E. You can. I mean, it depends on your calculator. And you need to take into account order of operations too. The other thing is this acidic or is it basic? So what I like to do here is we know H plus and OH minus. H plus in this situation, we just are told it's 4.3 times 10 to the minus 6. OH, we just found, is 2.32 times 10 to the minus 9th. Which one is bigger? H plus or OH minus? This is more zeros in front of it. So H plus, right? So H plus is greater than OH. So is this acidic or basic? It's an acidic solution. Okay? Negative 6 is larger than negative 9. Does that make sense? All right, one more. Hydroxide ion concentration is 1.6 times 10 to the negative 5. So OH what is the hydroxide or hydrogen concentration? Is it acidic or basic? So KW is equal to my H plus times my OH minus. KW is what? H plus, we don't know. But we do know that OH minus is 1.6 times 10 to the negative 5th. So put that in the calculator to solve for H plus. So 1 times 10 to the negative 14 divided by 1.6 times 10 to the negative 5th. You should get something to the negative 10th. What? 6.25. And that would be big M, and that's equal to my H plus concentration. Now, which one's bigger? OH or H plus? OH. So what type of solution is this? Basic. Okay, so my little trick here is the total exponent has to be negative 14, right? That's the largest I can go. Because when I multiply this times this, H times OH, it has to be 1 times 10 to the negative 14. So if I do the math and my answer, I get a exponent that's 10 to the negative 19, I know I did something wrong.
If you just enter in the calculator like 1 times 10 to the negative 14, like divided by 1.6 times 10 to the negative 5th, you get the exponent of negative 20, but you have to do it where like it shows like a fraction.
So you either have to show it as a fraction.
It's like white equals, and then you do the top and the bottom.
So you either have to do it as a fraction or you can put it in parentheses. Okay? Because it's going to take into account order of operations. So when we add these two exponents here, what do they equal? 5 plus 10 is negative, so we have negative 15. When we did the other one, we had a 6 and a 9. What do those add up to? Negative 15. So I always look at my exponents and add my exponents together. And if my exponents add together to be either 14 or a negative 15, then I know I'm doing something right. If it's greater than 14, or if you have, or greater than 15, you're wrong. You've got to go back and see where you went wrong. Probably an order of operations deal when that happens. Any questions? So that's it. There's no homework for tonight. Finish it. You do have that homework for solutions that is due tomorrow.